Okay, so good evening, everyone. Am I audible to you guys? I think someone's mic is on. Can you please turn it off? Okay. Am I audible now?
Yes, ma'am.
Okay. Okay. So, shall we start with our session for week 4 lectures? Okay. So earlier, we discussed about the methodology for the life cycle assessment. Now, in week 4, we will look into some other examples on how to perform the life cycle assessment, and also we'll talk about the framework and methodologies, the ISO standard method that is used for doing LCA. We'll have a look into that as well. So, first, I'll start with the class with the quick revision that we usually have with all the content that has been taught in last week. So the first is the comparison of light bulbs. This is an LCA methodology where we need to compare CFL bulb, that is compact fluorescent bulb, with an incandescent light bulb, that yellow bulb that we used to have in our houses earlier. So we need to compare both the bulbs and perform an LCA to compare the like which one is better. So basically, we know that LCA study consists of 4 steps. So what are those 4 steps? First one is to define the goal and the scope of the LCA. Then we have life cycle inventory stage, in which we record all the inputs and the outputs to the system at all these stages, like from raw material extraction to its manufacturing, then transportation, then its use, and then its disposal. So we have a record of all the inputs and outputs that are involved in the whole life cycle of that product. After that, we go for the life cycle impact assessment. In that, we understand the environmental relevance of all the inputs and the outputs, like how they are, how each and every process is impacting the environment, and what kind of emissions are being created, or what kind of waste is being produced, or the and also the like about the carbon footprints, or the like whether the product can be recycled or not. All such that we look into this life cycle impact assessment. And after that, when we get the a single factor impact, like we get impact in a single value, then we interpret the results of the study, and finally we give the conclusion, like which product is better. So we have already read this cycle, that the life cycle of a product, the all the process associated with the product, wherever and whenever they might occur. First one is your resource acquisition, where extraction and transformation of raw material is done. Here we are concerned about the raw material related to our product. Then the manufacturing of the product is done, where either it is assembled, or it gets manufactured, and then it gets packed in certain type of boxes, and then it goes towards the distribution part, where storage, handling, and transportation is involved. After that, when it comes towards the retail stores, then we buy them and we go for the use of that product. And after its use, we have either three options, like maintenance, repair, and reuse. And when it's like whole life cycle is completed, then it goes to end of life management. Here, collection, recovery, valorization, recycling, and landfilling is performed. So this is the whole life cycle of a product. And when we are concerned about this part only, like from raw material extraction to your distribution part, then it is known as cradle to gate. Because after this point, the whole impact of the product is in hand of the consumer. Like now it can't be controlled by the manufacturers, so this is known as cradle to gate. And when we look towards the complete life cycle of that product, so this is known as cradle to grave. And in every stage some or the other impacts are there, so we need to have a look into that as well. In every stage we have certain impacts towards our environment or ecosystem. So now coming back to the life cycle of a light bulb. So first we have the stage of resource acquisition, in which extraction and transformation is there. And after that we have the manufacturing stage, with where all these materials that are being used for during the uh, formation of that incandescent bulb or the CFL bulb. What are the materials that are being used are glass, tungsten, copper, steel, aluminium, argon, the electronic components. Then we have some plastics involved, and then we have mercury and phosphorus. So these are the materials that are involved during the manufacturing phase. After that, we come towards the packaging and transport, that is the distribution phase. And after the distribution, when we start using them, then we have we need electricity for their use. So this is also some sort of input. And after that, when we come towards the end of life phase, then we have disposal either in the landfill or the incineration plants. So basically, first of all, what do we need to know is what is the function and the functional unit. So the bulb's function, the basic function of a bulb is lighting, right? Like to provide the light. So we all know that LCA is an accounting exercise. So the environmental impacts, like see, we have three terms. First is your environmental impact, then is environmental intervention, and then comes our LCA. So for environmental impacts, basically it is the perturbation of natural cycles by environmental interventions. And what are the environmental interventions? These are the change in state of natural environment due to human activity. Basically, the activities that we perform, like for example, we cut the trees, that is deforestation. So it is environmental intervention. And due to that, what environmental impact we get is soil erosion, like climate change, heating, raising temperatures. So these are the environmental impacts that we get due to our environmental intervention that we create. After that, LCA. So LCA is basically is an accounting process of all the environmental intervention associated with life cycle of a product. So during the entire life cycle of a product, what all environmental interventions we do that have a certain impact on the environment, that we try to record in a quantitative manner, not just qualitative. We need to have a certain quantitative values to define that impact. So that we do it, through this LCA process. Now, coming towards the life cycle inventory. So, firstly, we got to know the basic process life cycle of a bulb. Then we need to formulate the life cycle inventory. So, during each and every process, like from this resource acquisition towards manufacturing, then distribution, then use and end of life, we have certain inputs and outputs. The inputs, like for example, during the natural resource extraction process, we have certain inputs, for example, iron ore, crude oil, water, wood, solar energy, and also some land is being used. So these are the inputs toward for the first phase. Then what are the outputs that we get is we get some form of emissions in air, water, or soil. We have carbon dioxide, SOx, SO2, particulate matters, and VOCs being emitted in the air. Then for water, we have phosphates and nitrates. For soil, we have certain pesticides or metals that reach the soil during when we after the disposal of the product or during other processes as well. And then other environmental interventions include the radiations, heat, and noise that is being created. And so what will be the functional unit? What is the functional unit? So functional unit, in the case of a light bulb, what will be the functional unit? The functional unit is the basically, what is a functional unit? It is the given amount of function to which all inputs and outputs are related to. So what is the function of the light bulb? To give light. So what can be the functional unit? To give a certain amount of light for a specific time period. That will be our functional unit, right? So basically, functional unit and reference flow. So what is the basis to compare two products? We need to have a certain common ground on which we are comparing both the products. So the product comparison is the functional unit or the comparison basis. So in many cases, one cannot simply compare the products A and B as may have different performance. So we need to understand this point, that it's not always necessary that we the both the products can we can compare them as it is. We need to find out a common ground or a common function that both the products are performing, and based on that we can compare the products. For example, uh, comparing a milk carton and a returnable milk bottle. So when we need to compare a milk carton that is which can be used and thrown, it cannot be reused, and a returnable milk bottle that can be used multiple number of times. So when we need to compare both the products, what can be the functional unit? The function unit can be packaging and delivering 1,000 liters of milk. So that we what we have done here is we have found a common ground. Like both the products are being used for the packaging of milk. So we have quantified that term, that for like suppose कि हमें 1,000 liters of milk pack करना है. अब we can see that which is a better option. Either we can go for the milk cartons, or we can use the returnable milk bottle. Then only we can perform the LCA. So we need to have certain functional unit to perform the LCA. So again, the life cycle of a light bulb, all of us know very well. I've discussed this slide clearly. Now, defining the functional unit. So for both the units that we have, that is incandescent light bulb or compact fluorescent bulb, CFL, both the primary function is lighting. What we need to get from those two products is light. So the primary function is lighting, and the secondary functions, there might be possible that some other secondary functions are also involved with the product. For example, the incandescent light bulb can also be used for heating at some places. You have seen, like for example, if you want to some sort of bakery, like earlier in our school times when we used to visit some bakeries or some like bakery shops, they have those like they have a box made of glass, and they have installed some incandescent light bulbs inside those boxes. And they used to put patties like that we eat as a snack. They used to put patties inside that glass box. So what was the function of that light bulb there? It was not performing the function of giving us light. Instead, it was giving heat, and which used to just keep those patties, which was used to keep those patties warm. So that is a secondary function that we take from that unit, and it can also be used for to create an ambience, like some types of lights we used to hang in our balconies or in our garden areas to get to create a nice ambience. So these are all the secondary functions. The primary function is to get the light. Now we understood the primary function. Now what will be the functional unit? So the functional unit will be the service provided. So it will be providing 700 lumens for a certain amount of time, like for 10,000 hours. Now we have defined very clearly the functional unit, and it would be the same for both the products. So the reference flows, what is needed to achieve this, what is needed to achieve this functional unit. So to provide 700 lumens for 10,000 hours, we need 10 bulbs, 10 incandescent light bulbs, and only one CFL bulb is sufficient to give such amount of light for that amount of time. So these are all the reference flows. Now coming towards the life cycle inventory. So this is the life cycle inventory for a light bulb. So initially we have bulb that is packed in some cardboard box, and after that, to use this we need electricity. So this is the basic 1 degree inventory. So for the functional unit we have defined providing 700 lumens for 10,000 hours, right? The reference flows, this is the data that is collected by some analysts. So what is there for 700 lumens? Okay, so for 700 lumens for 10,000 hours, we need 228 gram of glass, 232 grams of cardboard, and 600 kilowatt hour of electricity. This is the requirement. Is the slide clearly visible to you guys? Like this is very small. Shall I zoom it a bit? N- Now is it better?
Yes.
Yes, ma'am.
Okay. So basically, we have certain inputs and outputs, like we used to define earlier. So for 1 kg of glass, for making 1 kg of glass, the inputs will be 94 gram of crude oil, 1 gram of iron ore, and 1300 liters of water. So this is your input for 1 kg of glass. Similarly, for 1 kg of cardboard, we need 77 gram of crude oil, 16 gram of iron ore, and 3200 liters of water, right? And similarly, for the formation of 1 kilowatt hour of electricity, we needed 1.3 grams of crude oil, 0.29 grams of iron ore, and 19,000 liters of water. So these are all the inputs. Now coming towards the outputs. What are all the outputs that are being created? So first up, we have 0.52 kg of CO2, then 0.26 gram of PM2.5, 1.6 milligram of benzene. So these are the outputs during the formation of 1 kg of glass. For 1 kg of cardboards, we have 1.1 kg of CO2, 0.32 grams of PM2.5, and 8.7 milligram of benzene. Similarly, for electricity, we have 23 grams of CO2, 5.8 milligram of PM2.5, and 6.61 milligram of benzene. So these are all the inputs and outputs for unit processes, right? And now per functional unit, we need to calculate the values per functional unit, right? So what we need to do is, like, this is, for example, considering the amount of crude oil, what amount of crude oil is required. So how we calculate it is, for 1 kg of glass, that is for 1000 grams of glass, we had 94 grams of crude oil, right? So for 1 gram of glass, it will be 1000 divided by 94, right? Oh, sorry. It will be reverse, I guess. Uh, yeah, it will be reverse, like 94 divided by 1000, and this should be multiplied by 228. For 1000 gram of glass, we had 94 gram of oil. So for 1 gram of glass, we'll have 94 divided by 1000 gram, right? And what, how much amount of glass we needed? 228 grams. So for 228 gram of glass, we'll have 94 divided by 1000 into 228. That is equals to 21.43 gram of oil. Understood? How do we calculate the all the values per functional unit, right? Similarly, we can calculate for iron ore or the water requirement, and all the values, like all the inputs and outputs, we need to calculate per functional unit. Understood? अभी इस प्रोसेस में अगर किसी को डाउट आ रहा है दैट हाउ डू वी कैलकुलेट द अमाउंट पर फंक्शनल यूनिट, आई कैन गिव वन मोर एग्जांपल, आई कैन टेक एनी अदर वैल्यू एज वेल, और शैल वी मूव फॉरवर्ड? Is it clear?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Please
Okay.
go ahead.
Okay, so we'll move ahead. We have defined the functional unit, we have created inventory. Now, we've also discussed this also. So, for the elementary flows, we have certain inputs and the outputs, but inventory make out hundreds of different elementary flows. So, we to make the life cycle assessment, that data sheet a bit simpler, what we have done is we have neglected the processes in neglecting the process in the process tree which contributes to less than 0.1% of the environmental load. So this we have assumed to make the process a bit simpler. Now coming towards the central database. So this is eco invent database. Basically these are the six Swiss organizations, and that joined forces to create the eco invent database, and these are all different types of database. First we have EMPASG, which gives the data for the plastics, paper and board, basic chemicals, detergents and waste treatment. Then we have FAL, that gives us the agricultural database. Then PSI gives you energy supply. ETH gives about the basic chemicals, then ETH-UNS gives the data about the transports, and EMPADU gives the data about the metals, construction materials, woods, and basic chemicals. So this is these are organizations that we are seeing here. They have created a central database system, and we can access this uh, for our educational purposes for free of cost. And they have created databases for certain countries, and they are also working on creating databases for our South Asian countries as well. So we can access their database to get the information about the life cycle inventories. Now, coming towards the life cycle impacts. So, we all knew about, after knowing about these elementary flows, what are the basic impact categories that we need to consider is, so first off, we have global warming, then we have ozone layer depletion, land use, then natural resource depletion, then we have acidification, eutrophication, photochemical ozone regeneration, human toxicity, and ecotoxicity. And all these one or more, maybe all these, or maybe one or two, or maybe some of the categories we consider during our LCA process, and we try to convert that into a single score, that is your impact score. So this is a methodology for the for performing the LCA, that is impact 2002 plus. So we have all the elementary flows, we have certain impact categories, and then we try to convert them into, we try to categorize them into a certain categories, certain damage categories. For example, all these impact categories cause damage to human health. Some of the impact categories cause damage to ecosystem quality. Similarly, some cause the climate change and some cause damage to the resources. So we have tried to compile all these number of impact categories into a broader classification, like we have compiled them into a single unit. Then these are called like, we have the LCI life cycle inventory results. Then we go towards the midpoints. So for example, see, these are all the midpoints that we get from the life cycle inventory analysis, and we try to convert these midpoints to the endpoints. These are all the midpoints, and these are all the endpoints of this study. So this is the general overview of the structure of an impact assessment method, and these are characterized to produce a number of impact category indicators, as discussed earlier. And according to ISO, one must document the environmental relevance of each indicator by describing the link to the endpoints, like how the endpoints are linked to the all these impact categories, and we can select the endpoints, but as long as the reasons for including or excluding the endpoints are clearly documented. So these are all the like type of, basically the choice of the impact assessment method or the impact categories depends mainly largely on the audience address, like for what audience we are trying to perform this life cycle assessment, that determines the method that we method or the impact category that we need to focus upon. So these are all the results for the life cycle assessment. We can make broadly, these are all the impact percentage. So we can clearly observe that the maximum impact has been observed during the use phase of the bulb, that is due to the use of electricity, because the source of electricity that we have is generally either thermal power plants. So they create they firstly they use a large amount of water. That is also one sort of impact, and they also create a large amount of air pollution. So that is why the maximum impact has been observed during the use phase. And see, these are all the midpoint indicators that we have considered here. And here, these are all the endpoint indicators like climate change. This is resource extinction. Now, coming towards the benefits and the drawbacks of this LCA process. So basically, this LCA is an assessment method, and it gives us information, like the quantitative information about the processes involved, and the it quantifies the impacts that are being created by those processes. Then it is also comparative analysis. The results are relative with this, like we compare one product with the other, and also it covers all the environmental aspects, and the product, service or corporation, that is a system approach is there. And we have an overall idea of the complete life cycle of a product, that is cradle to grave, that we have in LCA. So the key features of the LCA is the complete life cycle analysis of the product is done, and also we cover all the environmental aspects. That is why it is a global perspective. And basically the depth of the LCA varies as per the goal of the study, like how much detail we are going to consider the impacts, or what all the key indicators that we need to consider during our LCA study. Uh, it needs some resources, that is time, money, software tools. Everything is required to perform an LCA exercise, and the choices are unavoidable. Unavoidable. This is a subjective type of study, and there's no scientific basis to reduce the results to a single score. So we need to have perform value choices. Then so this is another thing, that is problem shifting. So what we do is we shift try to shift the from a certain problem to other. Like earlier in the previous class, I was giving an example of these e-vehicles. So this is a case of problem shifting, like where we are shifting the problem of pollution on the roads by uh, by shifting towards the e-vehicle. But in the end, what is happening is, since we need to charge those e-vehicles, like we need electricity, and for the production of electricity, we are using a lot of amount of water, and also we are creating a lot of air pollution. So what we are doing is, we are shifting from one problem, like the problem of the roads, we are shifting towards some other area, like towards the production of electricity. So this is known as problem shifting. Like for example, in time, like problem shifting in time is recycling products that contain heavy metals. So is it worth recycling the products that contain heavy metals? It totally depends on the process that are being involved towards the recycling of those products. And similarly, exporting hazardous waste, replacing zinc gutters by gutters in PVC, or incinerating waste that contain heavy metals instead of landfilling them. During the during this process, some emissions are also there, and they are creating some emissions. So it's definitely some other environmental problem must be getting created due to this incineration process. Then reduce acidifying emissions by increasing the greenhouse gases. Same same is two other consumption patterns is there, that is spending savings from fuel efficient cars on holiday flights. So this is shifting of one problem to the other. Now, evolution of environmental preoccupation is not that much important. Let's see, modeling of reality. Okay, same is there, LCA modeling of reality, like what how do we create the LCA models during the software, the function. We have a certain function and functional units. Then these are economic models. Then when we go towards the inventory part, then we have production inventory and elementary flows inventory. These are known as technological models. Then for the impact assessment part, we have impact category indicators, and which are further converted into a single score. So these are environmental models. And what are the limitations of these models? That is not real impacts or exceeding of thresholds, or safety margins or risks. And these are due to the fact that the relative expression of impact scores related to a reference unit, that is known as functional unit. Then integration of environmental data over space and time, inherent uncertainty in modeling of impacts, and the fact that some impact categories clearly represent future impacts. So these are the limitations to the model. other limitations are that the only environmental aspects are being covered. The social and economic aspects are covered with other tools for social impacts. We have social LCA, and for economic aspects, we have life cycle cost analysis, life cycle costing analysis. This will include your economic impact, that is LCCA. For inventory, so basically not all processes and flows are involved during the inventory, during the record of the inventory part, and the quality of data that we get is very much important. Like it should be validated that before performing the LC exercise. And for the impact assessment, the chosen impact categories are very much important, and uh, we have certain available characterization models that only we can use them only. And we need there's a limitation of the relevant inventory data. Every time is it is not possible to have all the data that is needed to perform the LCA exercises. So decisions with narrow perspective. So this is also a case of problem shifting that we just read. So in the early 1990s, California had a policy goal of reducing emissions. So of air pollution by encouraging the adoption of zero emission vehicles. So what they did is they shifted the diesel or the gasoline vehicle. Sorry, they shifted from the diesel and petrol vehicles towards the zero emission vehicles, that is electric vehicles, and into 2% of the fleet by the year 1998. So they targeted that the 2% of the fleet of the vehicles will be the zero emission vehicles by the year 1998. So what the problem was there is these vehicles were battery powered and the battery was lead acid. So we have already discussed that lead is very harmful, and apart from that, these vehicles were battery powered, so the battery needs to be charged. And same problem, battery charging, then that means we need electricity, and more electricity, that means more pollution. So this is the problem, is the problem of shifting, that they try to reduce the pollution on the road, but what they did is in to reduce the pollution on the roads, they increase the burden on the production of electricity, and due to that more pollution was being created. So this is a decision with narrow perspective that is there. And the study in Science by Lave et al. 1995 suggested that this policy would not achieve its intended goals. So, what were the problems? Like, for example, as I've discussed, what were the problem with this solution was the cars fully powered by batteries. So, the batteries of this type need to be recharged, and recharging happens with electricity, and electricity produces has air emissions, right? So this was the major problem. Also, at the time, batteries were lead acid. So large amount of lead is needed for the manufacturing and recycling emissions of lead. And compared to the scenario when no zero emission vehicle was there, it was creating the more amount of lead was getting released. So this was also a problem. So an LCA could have pointed this out very clearly, but earlier, since we didn't have this LCA methodology, so that is why this policy failed. So initially, what is the history of LCA? Coming towards the history of LCA. So initially, the LCA work was focused on majorly on energy part, like what are the inputs in terms of energy that we are giving in every process, and what are the outputs that are being generated. And in 1969, the first first multi-criteria study was performed by Coca-Cola, and this was done for this was in term type of LCA exercise where they had to make a choice between the glass bottles and the plastic containers for packaging of their cold drinks. And the choice between internal and external container production was also there. Then they had end of life options, that recycling or one way. Then the result of that exercise was that the plastic bottle was best, contrary to the expectations. And but this study was never published, and the questions of validity then occurred. And this led to calls by scientific community for a standardization process. So we need to have a certain standard process, like we used to have for our experiments that we conduct in our lab. For example, for our environmental engineering lab, we have a certain manual. So we perform every single experiment according to that manual only, just because we need to standardize those process. So just like that, we need to standardize this LCA process also. So this is the timeline of the development of the LCA, how the guidelines were formed. Like in between 1997 to 2000, we got ISO 14040 standards, and also we have some European LCA platform. Then social LCA guidelines were formulated in before 2010. So these are all the timelines. And then coming towards the ISO framework. So this ISO framework is basically um it it acts as a manual or a standard guideline to conduct any LCA exercise. So for ISO framework, ISO 14040, we have first we have it has four phases. So first up we have the goal and scope definition. Then we have life cycle inventory, then life cycle impact assessment, and at the last stage we have interpretation. And we can clearly observe that every single stage is interrelated to each other. Then after that we have its applications. So this process is iterative. The collected data may lead to the modification of the scope of the study. For example, we have during the formation of the life cycle inventory, for example, and suppose we don't have the data for certain process or certain uh, activity. So we need to modify our scope or the definition of the modify our scope of the study accordingly. So this is that is why it is an iterative process. And in some cases, the goal of the study can also be revised due to the limitation of the data. So what is the goal of the study? So basically the goal is what and the what for of the study. So what should be defined by the goal of a study? The goal must clearly define the object and the reason and the intended application of the study. So these are the things that are being defined in the goal of a study. Then coming towards the examples, some of the examples from ISO 14040, these have been directly taken from the code only. So identifying opportunities to improve the environmental performance of products at various points in their life cycle. These are some of the goals of the study. These are from some of the examples of goal of a study. Next is informing decision makers in the industry or the government or non-government organizations for the purpose of strategic planning, priority setting, product or process design or redesign. Then the selection of relevant indicators of environmental performance, including measurement techniques. Then marketing, implementing an eco-labeling scheme, making an environmental claim, or producing an environmental product declaration. So these are the types, some different types of goals that we can have for a particular study. Then the ISO framework. Did Okay. So what do we get from the goal of the study? So the goal will guide us towards the depth and the scope of the study. So having a clear goal for a study will give us information about all the systems that are being studied in our LCA method, functional unit and the reference flows, the system boundaries, the initial unit process inclusion criteria, then the allocation rules, inventory data requirements, And then life cycle impact assessment methods we have there, and we need for a critical review that is clearly defined by a goal of the study. Then function is the starting point of any LCA methodology, and uh, we need to define the function and the functional unit. So the functional unit, in defining the functional unit, we define the calculation reference, the system boundaries, the included unit processes, and not always easy to identify the function of the system. Some systems may be multifunctional, so we need to clearly observe that what are the primary functions and what are the secondary functions, and we need to give priority to the primary function for a specific object that we are going to perform LCA for. We need to differentiate between primary and the secondary functions. In comparison, systems may have the same functional performance or the same functional unit. They must have the same functional performance or the same functional unit, not may have. They must have the same functional performance and the same functional units. Now, the reference flows. So, what are the reference flows? The reference flows are the amount of products necessary to fulfill the amount of function specified by the functional unit. Like earlier, we did it that exercise for incandescent bulb and CFL bulb. So, the reference flows are the amount of products that we calculated for all the steps, the input and the output values, and what must be purchased in order to fulfill the function. Different for each compared system, often related to the functional unit by key parameters for the optimization of the system. So it is related to the life of the product, the number of uses, and the amount of matter, that is energy used or the efficiency of the product. So now coming towards the unit processes, data, and life cycle inventory databases. So for the unit process, a subdivision of the product system assuring a unique or a group of activity or operations. So we have two types of flows, that is inputs and outputs. First is intermediary or the economic flow, that is linking two unit process. One or more represents the function of the unit process. Then we have elementary flows, that is linking the unit process with the environment or the environmental intervention. Then so this is a flow chart about the unit process, that we have some elementary flows to unit process one, and we are getting some output from the unit process one. Then we can have other unit process, then or maybe these both process may be linked. For example, during a formation of a product, we have raw material extraction, then we have manufacturing. So both are the different unit process, and we have different flows for the input and output of that process. So that's it for the theory part. And now we'll have some questions. Today I couldn't add those questions in the slide, so I'll just write down the questions, and then we'll go for the answers. So the first question we have is, I'll just quickly write down the question. What is the first step in the study of LCA? The options are understanding life cycle impact. Option B, defining goal and scope. Option C, analyzing this life cycle inventory, and option D, none of these. So I hope the handwriting is clear to you guys. You guys can read the question. So, anyone may tell me what will be the answer?
Maybe
Option
B.
B.
Divine goal and
B.
scope.
Yes, defining the goal and the scope. This is the first process. And what we, after that, after the defining the goal and the scope, the what will be the second process, if anyone can tell me?
A.
C, ma'am.
Okay, yes. We need to create the life cycle inventory. After defining the goal and scope, we need to go for the like function and the functional unit. Then we formulate the life cycle inventory, and then we go for the life cycle impact assessment, and then we formulate the results. So this is the whole process. Now, for the second question, I will quickly write that down. Uh, how many independent parameters human brain can consider during solving a problem? This topic we have discussed during uh, when I was telling about making endpoint and midpoints, like for the impact parameters. The options are 3, 5, 7, 10.
7.
7.
7.
Correct. Now, for the third question, which of the following organization doesn't contribute in creating eco-invent database? Remember that six uh, Swiss um company organizations that we studied that constituted the eco-invent database: SEMA Pro, ETH, UNS, ETH, LTC, ETH, PPC. What would be the answer?
A. SEMA Pro.
Sigma Pro.
Right. Uh, which of the following material has highest CO2 emission in its production? 1 kg high density polyethylene, 1 kg low density polyethylene, 1 kg PET, and D is 1 meter cube of concrete. So, any idea about this?
No, madam.
Concrete.
Correct. who's ये किसने आंसर किया है concrete?
Myself, Sudhir Kulkarni.
Correct. Your answer is correct. It should be 1 meter cube of concrete. Now, the next question is, which organization first worked on LCA? A. Government of California. B is Coca-Cola Company. C is Environmental Report on Packaging. D is Eco Invent Center. First work on LCA was done by
Coca-Cola
Coca-Cola.
Company.
right,
Option B.
Coca-Cola Company. Next question is, what are the major compounds causing aquatic eutrophication? Phosphate. B is carbon dioxide. C is nitrate. And D is sulfur dioxide. Anyone?
Option A and
Phosphate. Phosphate
the
and
option phosphate and nitrate. A
phosphate
and
and
B.
nitrate.
Okay, so can anyone explain me the process of eutrophication? Like, what do we understand by eutrophication?
It forms something like a blue algae on the water surface.
The
That is
lack
what.
of nutrition in water bodies, aquatic bodies, because of excess algal growth, algal blooms.
It may not
It
allow oxygen.
Sorry,
It
oxygen, lack of
doesn't
oxygen,
allow
Actually,
lack of
it
dissolved
starts
oxygen.
from the whatever fertilizers we use, which seep through the water bodies from the groundwater, and then all that starts.
Correct, correct. You have clearly defined the major cause of this eutrophication problem. Basically, whatever the fertilizers that we apply on the field, they tend to flow out with the runoff, and they start entering the nearby water bodies. And due to the increased concentration of the plant nutrients, what is there is there is an increased biomass generation on the surface of the water, and due to this, oxygen level in the water reduces. So this is the process of eutrophication, right? Now the seventh question we have, which of the following tools are used for environmental assessment? Is risk assessment, B is environmental impact assessment, C is substance flow analysis, and D is impact modeling. So For the environmental assessment, what tool we generally use is
Substance flow analysis, risk assessment, and substance flow analysis.
uh,
A, B, C, ma'am.
Yeah,
correct.
EA also.
Yes, AI is also mandatory for the environmental assessment of certain projects. So all these three are there for environmental assessment. Eighth question is 1 kg of CH4 emission is equivalent to 20 kg of CO2 emission. A is true and B is false.
False.
Then, if anyone may tell me what exact amount
25
it will be.
kg.
Okay, right. So it should be false. Ninth question. It is necessary to adopt same functional unit for the comparison among two different systems. True or false?
True.
True.
Op-
Right.
Option A.
Like, yes, like our whole study is based on this concept that it is very much necessary to adopt the same functional unit for both the systems. And the last question we have is compact fluorescent bulb gives more heat rather than incandescent bulb.
Fails.
There's no need to give options for this question.
Yeah,
Correct. It should
true.
be false only.
That's only.
It should be false, right?
Yes, ma'am. It is false only.
Someone actually said true, so I needed to confirm this. Okay, so it's false, right? So we have discussed all the 10 questions of the previous year assignment, and also the we had a quick revision of all the topics that were covered into this in this week. So actually, I needed to ask you guys something that I have a class that clashes with this class only. That from 6 to 8, I need to have some other class as well. So, are you guys comfortable if I shift this class from 4 to 6, or maybe on the weekend, first half of the weekend, like Saturday, anytime like from 11 to 1 or something?
Madam, Monday to Friday evening hours is fine, madam. After 6.
Okay, Monday to Friday, after 6, anytime.
Any day. For me, it's okay.
Okay, so
Monday to Friday, 4 to 6 also it will be okay for me personally, but not on the
okay,
weekend
for
then.
what? Okay, so okay, let's skip that weekend part. So, is it fine for 4 to 6 for if any day on Monday to Friday from 4 to 6, is it fine?
Uh,
5 to 6 will be
Yes.
better. Means after 5 will be better. Before 5 it will
Okay.
be difficult.
Okay, some of you must be having your classes, right?
Yeah.
Okay. So after 5,
And Miss
let me.
Ria, I have, ma'am, I have one question.
Yes.
Which book I should refer for polymers related life cycle assessment, like individual ingredients, carbon footprint level I need to understand. So which book I should refer for, especially for polymers? Maybe
Okay.
polymerization process, or the uses of polymers related to that.
Okay. So, see, my background is more on environment. So, right now, I exactly don't know about any standard book for that, but I'll share the name of certain books. I'll consult this with my professor only, and I'll
Sure,
definitely let you know some book. I'll share the name in the chat box, or I'll just in the next class, I'll tell you the name of certain books, right?
sure,
Book
definitely.
you need book for polymer, like life cycle
Polymers
assessment.
related, yes. Like you
Okay.
mentioned, the uh, carbon footprint with LLDP, LDP,
Right.
and
Right.
so I want to know all polymers carbon footprint.
Okay.
uh, I want to know paint. If any solvent we are using in a paint and
Yes.
we are having water-based paint, what will be
Okay.
the difference in carbon footprint in that case? That kind of knowledge I want to gain. So
Okay. I'll definitely discuss this with the professor, and I'll definitely let you know about any standard book that if he suggests, or any standard book of LCA that you guys can follow for that purpose.
yeah, your email ID is
Yes. Yes.
varmaria.2807 @gmail.com. So I
Yeah.
will send on email also to you for this
Sure.
request.
I'll
So it
just
will be in
inform
your
you
mind
know.
for long.
Okay.
Yeah,
Okay.
yeah, sure. Ma'am.
Okay, so any other thing that you guys have? I'll just see if I can switch this class, or else I think this time is fine if every one of you is comfortable with the 6 to 8 time. So we'll just continue with this timing only. I'll try to shift my other class at some other time. Okay, so that's all for today's class. I'll see you guys next week.
Thank you, ma'am.
Okay,
Thank
thank
you.
you so much. Thank you. Bye.